Well, good luck. Okay, so anyway, so that's the find command, and it's quite useful. You can see that you can extract essentially information using logical operators from an array of numbers. Extremely valuable. Extremely valuable. So let's now watch another video where we learn about the selection. We're going to learn about selection operators, selection commands. They call them branching structures here.
Hello and welcome to the screencast on branching structures in MATLAB, the if-else construction. In this screencast, we're going to discuss conditional statements and branching in programs in general, look at the if-else construction in MATLAB and its relative to the if-else-if construction. So many times in life we're given information and we have to make a decision based on that information. For example, when I get my kids ready for school in the morning, I need to know how to dress them. And inside my brain, there's a little algorithm that might say, if the temperature outside is less than 50 degrees Fahrenheit, then the kids need to wear coats. Now, this is a conditional statement, an if-then statement, where we input some information, namely the temperature outside, and then we produce output based on a condition set for that information. If it's below 50, then they need to wear a coat, and I have to tell them so. Otherwise, if it's 50 or above, they can wear a coat if they want to, but it's not necessary. And so the output could go two different ways depending on what the input is. Now, if I were programming a computer to make this decision for me, the algorithm might go something like this. First of all, the known quantity here is the outside temperature. The unknown is whether or not we should wear a coat. And the assumption here is that we're going to enter in units in degrees Fahrenheit. So the algorithm would flow like this. First of all, I would input the outside temperature to my program. And then I would have to make a decision. Is the temperature less than 50? If so, now...
So you can see here that he's using a form of flowcharting almost. Flowcharting almost always starts with just a list of descriptions of what you're going to do, like he's doing here. And then it goes to some kind of actual graphical charting.
I would display put a coat on to the screen. If not, I would display you don't need to wear a coat to the screen, and then I would simply end the process. Now that's a well-constructed written algorithm since the scope is well-defined. All the steps are written sequentially, and the one question that has to be answered here is clearly a yes-no question. Now, as a flowchart, this is what it would look like. Notice that when we have to evaluate the temperature there on the diamond, there's a fork in the flowchart. That's why we sometimes call the evaluation of conditional statements a branching process. Having to evaluate an if-then statement splits the flow of the process into two streams, one for a yes answer and one for a no answer, and the output depends on the answer to my question. Now let's go to MATLAB and see how branching is implemented in a MATLAB program. So let's build an M file to make the coat-no-coat decision for us. Following my graphical algorithm, I first need to ask the user for the temperature, and I'm going to say temp equals, use the input command to solicit input, and just ask the user, please enter the outside temperature. Might remind the user to enter that in degrees Fahrenheit. Close the string and close that, the semicolon. And that implements the first little box in my flowchart, but now I have to do something with the value of temperature that's been entered. Now in plain English, I would say something like, if temp is less than 50, display put on a coat, otherwise display you don't need to wear a coat. And that's pretty much how we're going to do it in MATLAB, except in MATLAB, this is how it looks. We would type if temp less than 50.
Notice that that if comes up in blue, which means MATLAB recognizes it as a built-in function. It knows what to do.
Hit enter, and notice it indents for you. Display, I'm going to use fprint f, put on a coat with a new line at the end. Close that. And then that's the first condition. The second condition is that
you could have also used display there if you wanted to.
Otherwise I would display you don't need to wear a coat. Now I'm going to back indent out to this level and type else. Else, hit enter again, and notice it indents for you again. Fprint f. You don't need two apostrophes there. You don't need to wear a coat.
So if you want to use an apostrophe in the middle of a string in fprintf, you have to use a double one then it knows that it's using an apostrophe there and not just ending the string.
And the line and the string, and that's that. And then I need to tell MATLAB to end the process, which I'm going to do with the statement end.
So all if statements should be ended, just like your functions, your user-defined functions were ended.
So let's take a look.
So if I was a statement, it would be if the temperature is less than 70, then I would complain about it.
Sure.
Look at this code. We'll expand this out so we can see everything. First of all, the line 3 here asks the user to input the outside temperature, and it stores it in the variable temp. But then this block here is where the decision gets made. The if line sets up the first condition. If the temperature is less than 50, if temp less than 50, in other words, is true as a Boolean statement, then MATLAB will kick down to that command right below it in line 6 and put on a code to the screen. If temp less than 50 is not true, in other words, otherwise, it will kick down to the else line here in line 7 and execute the command that's just after it, namely that fprintf, you don't need to worry code, and then it ends the process. Now let's save this file to, let's call it coat.m, and run the program and look over here in the command window and see what happens. So I enter in the outside temperature, and let's say it's 66 degrees outside, and it will display you don't need to wear a coat. If I run it again, and enter in something less than 55, it will say put on a coat. And if I run it again and give it a temperature of exactly 50, I think I said 55, and then 50, if it's exactly 50, technically speaking, I should not have to wear a coat because I said less than 50, and in fact, that's what the program does for me. So back over to the M file, let's make a few notes here. The block following the if and the else statements here can contain an entire string of commands. It doesn't have to be a single line. And note that since there are only two options for temp here, it's either less than 50 or it isn't, I don't need to set up another condition here to say something like temp greater than or equal to 50 because there's only two options. If temp is less than 50, do one thing, otherwise do the other thing. Thirdly, note the indentation in this if-else statement. The indentation is not strictly necessary like it is in some programming languages, but it does help readability quite a bit. I can just look at the indentation and see which commands go with if or else. So that's the if-else construction used for making simple, single yes-no decisions in MATLAB. We set up the condition with if, give it the commands to execute if that statement is true, and then else, and then set up the layers of commands to execute if that's not true, and then tell it to end. Now let's suppose the decision-making process is a little more complicated, and instead, for dressing my kids, I use the criteria if the temperature outside is below 50 degrees or it's raining, then the kids need to wear coats. This time there's multiple criteria to think about, and here's what a graphical algorithm for this situation could look like. It's got some of the same elements as before, but now I have two conditions to monitor, namely the temperature and the precipitation. If the temperature is below 50 degrees, then I know what to do, but otherwise I have to check the raining status and make a decision based on that input. So we have a chain of if-then contingencies. Let's see how this is managed in MATLAB. So let's go back to my coat.m file, and I've added one line here in line 4 that basically solicits the user's input as to whether it's raining or not. Since I only want the user to say yes or no, I'm going to pass a graphical menu to the user using the menu command, and they're going to click yes, in which case the value of raining will be set equal to 1, or click no, in which case raining will be set equal to 2. So now let's go down here and look at the if-else structure and see what we might want to change. The if statement.
So that's something you haven't seen before, but it's a built-in graphical user interface, essentially. I'm not sure if it's the same in the newest version of MATLAB. Have you tried it yet? The menu command?
I got one other random question. How do you put an apostrophe in the middle of a string without making it?
You do a double apostrophe.
Double
That's what he just showed us right here. Double apostrophe. What's that? So the menu command works? Okay. Yeah. So menu brings up a little click box, right? And it asks this question and it gives you however many options as buttons. So you can click on it. And it will give you whatever button you click on. If you click on the first button, it'll return a 1. If you clicks on the second button, it'll return a 2. Clicks on the third button, it'll return a 3, and so on. So it's very simple.
Here in line 7 and 8 are fine as it is. If temperature is less than 50, then I do want it to tell me to put on a coat. But now for the else, I'm going to have to change a few things because I'm going to implement another if-then statement. Now in MATLAB, we implement this using the structure called else-if. So if temp is less than 50, then it knows what to do. Else, if raining equals 1, that is, if the user said that it's raining outside, I also want it to tell me to put on a coat. I'll just copy and paste this line, like so. Now, if raining is not equal to 1, then I want to do yet one more thing. So I'm going to have else to catch all the remaining contingencies. And this would be a situation where I want it to tell me not to put on a coat. So let's walk through this logically one more time and see what happens. It inputs, or the user inputs temperature as a number and raining as a value of either 1 or 2 for yes or no. If the temp is less than 50, then it prints out put on a coat and the process ends. Else, if raining is equal to 1, that is, it's raining outside, it says to put on a coat. Else, you don't need to wear a coat. That's the only option left over. And the process ends after each of these little blocks, if, else if, or else. And let's just see if this really works. When I run the program here, if I enter in a value of 44 for the temperature, and there's the menu that pops up, and I tell it that it's not raining outside, it should tell me to put on a coat. Although it's not raining, it's cold enough I need a coat. If I click it, run it again, and give it a sort of a warm temperature, like 66, and answer yes for raining, it'll tell me to put on a coat. If I give it a warm temperature and tell it that it's not raining, it'll say that I don't need to wear a coat. So everything seems to be working properly. So this if, else, and construction can be used to create a chain of yes-no decisions that if we've covered all the bases of our decisions and not left any options out, it'll always connect the input to the right output. However, you might notice we can do this in a little bit more efficient way. For example, if I just go up here and type in the exact statement that I said before, if the temperature is less than 50, and use a logical operator, or raining equals 1, then put on a coat, I don't need the else if. I can just use else. So this is a shorter way to implement the same process in code. And this just goes to show you that there's more than one way to do anything in MATLAB or in any programming environment. So although you can use if, else, and kinds of constructions to make complicated chains of reasoning, you often don't have to.
So that's the if, else, if, and else if statements, branching statements, right? Branching operators. So these are the first we call structures, selection structures. In this book they call them selection structures, where MATLAB selects things based on the logical operators that you use, the logical programming that you use, right? So if else if, else if, and else. You can use them all together. Make sure that you end them at the end. Right? They do a classic example of a grading program in here where they have a whole bunch of grades, and then they use the else if thing to assign each person a grade. Any questions about the if, else, if stuff? Okay, the last one is what we call the switch case.
Hello and welcome to the screen cap.
Switch case structures, which is another type of selection structure. It's a little more, I would say, I'd say it's a little more complex.
On branching structures in MATLAB, we're going to look at the switch case construction. So in the if-else screencast, we looked at conditional statements and how they cause branches in the flow of a program when we have to evaluate yes-no decisions. There's another kind of branching where we have to evaluate output of a question based on the input, where we decide output based on whether our input belongs to one particular case of inputs or another. Here's an example. Let's say I want to write a program that classifies letters of the alphabet as vowels or consonants, or maybe it's the letter Y. So of course you know a vowel is the either letters A, E, I, O, and U, and consonants are everything else except the letter Y, which is sometimes a vowel and sometimes a consonant. So I want the user to enter in a letter. Let's assume it's a lowercase letter of the alphabet, and the program prints out your letter is a vowel, or your letter is a consonant, or your letter is the letter Y. Now, a flowchart for this algorithm might look like this. We enter in the lowercase letter. We decide whether it's A, E, I, O, U. First of all, one of those 5 letters. If it is, we just tell the screen that the letter is a vowel. If it isn't, we might check that it's Y, and then we'll print that out. And if it isn't any of those 6 letters, we're just going to print out it's a consonant. So let's go to MatLab and see how we might code this up. So over here in my M file, I have a letter decider program. It's called letterdecider.m. And let me just walk you through each line of the code here. First of all, line 3 is the first line that executes. And it prompts the user on the screen to enter in a lowercase letter. And obviously, I want this to be a string variable, so I'm passing the S option at the end of that input statement. So the user will enter in a lowercase letter, hit enter, and it will store it in the variable letter. Now, here's where we go about deciding what kind of letter this is. It's an if-else-if-else end construction, and right away you can see this isn't very pretty. Well, let's see how it all works. In lines 5 and 6 here, we are basically going to say if the letter is equal to A, or the letter is equal to E, or the letter is equal to I, or the letter is equal to O, or the letter is equal to U, an entire string of or statements, then we're going to print out the letter as a vowel. Else, if the letter is not equal to Y, we're going to say it's a consonant. And if all else fails, we're going to print out that it was Y. Now, this program works, and we can go over here and run it and see that it works. Enter a lowercase letter, let's put T, and it says it's a consonant. Run it again, and if enter a lowercase letter I, and it says it's a vowel, run it again, and you enter Y, it tells you that you entered Y. So it works, but it's not terribly efficient, mainly because there's this long string of OR statements. And that might be okay for this program because we're trying to lump my letter into a case of 5 possible values. But what if it's not 5 possible values, but 50 or 500 that I want to sort through? Then we get really unreadable in a hurry. And really all we're trying to do here is sort the input into one of 3 cases. Either it's a vowel, or it's the letter Y, or it's a consonant if it's not in one of those first 2 cases. So there's a better way in MATLAB to handle this situation, and it's using the 2 commands switch and case. So I'm going to go over here to another M file that I have going. That's going to be an improvement upon my letter decider M file. And we're going to start typing here. First of all, we're going to leave the first line unchanged. I'm still going to have the user enter in a lowercase letter, and that's a string, so I pass it this S. The first thing we're going to do is type switch letter. This tells MATLAB we're about to tell it how to produce output by switching through the various cases of the variable letter. We're switching letter. Now we're going to type, if I go down here, it will automatically indent case, and then a curly bracket, and then A as a string value, E, I, O, and U, and then close those curly brackets off. After the case, I'm going to hit enter, and it indents again, and I'm going to type, say, F.
So in case you're not remembering, when you use these curly brackets, you can make an array, what we call can't remember what they're called, but anyway, you can make an array of strings this way, right? So
F print F, your letter is a vowel, with a new line on the end. Now, before we go on, what's just happened here? When switch letter is invoked here, MATLAB's going to take the variable letter, and first of all, it's going to see if the letter falls into this case here. Is it A, E, I, O, or U? If so, print out your letter as a vowel. Now, this is a little bit better than an if-then statement because I don't have to execute a whole bunch of OR commands or conjunctions in between a bunch of logical tests. It just tests to see if my letter is in this little bracket set here. Now, maybe it's not, in which case I'm going to go to another case, and notice it back indents automatically. And let's suppose I want to check and see if it's the letter Y. So in case, I said these curly brackets, in case the letter is Y, I'm going to F print F, your letter was Y, and then have a new line. And so in this case, literally in this case, if letter is not in this set, it's going to test to see if it's in this set. And if it is, it will F print F that my letter was Y, and close that quote. Now finally, there's one last case that could happen, and that it's something other than the previous 2 cases. Now, I don't have to add a new case for this. I just need to say the word otherwise. F print F, your letter is a consonant. And add a new line there. I'm going to put a little bit of space here. And then I'm going to type N, and it will back indent and light up with the initial switch. So let's walk through this code one more time. I have the user enter in a lowercase letter and store it as the variable letter. In line 5, MATLAB is now going to take that variable letter and switch through 3 different possibilities. In the first case, it's going to evaluate the output on a case-by-case basis, literally. In the first case, if it happens to be A, E, I, or U, if letter happens to be A, E, I, or U, it's going to print this off. If not, it moves on to the next case and checks to see if it's in there. If it's Y, then it's going to print the letter was Y. In all other cases, if it falls through the first 2 cases, it's just going to print that the letter was a consonant.
So I want to point out that you can either have many cases or many cases and an otherwise. You don't always have to have an otherwise in it. But this is what this does, is it just looks at the thing that you've input at the beginning, which is in this case called the thing letters, this thing called letter, and then it just looks through it and it says, is it this, is it this, is it this, is it this, does it fit this situation, does it fit this situation? And then whatever it does, it implements the code that you've written under that particular case. So that's why it's called the case switch. In this case, this switch is not like switching with something, it switches on a case. It turns on the program under its particular case, essentially. So the switch is here, the cases are here. So this is called the switch case thing. So once it gets to a case that it's satisfied by, it runs that and then it ends.
So it won't necessarily run all of it?
No, it won't necessarily. I don't think it'll run more than one case. Like if it fits 2 different cases, I don't know if it'll run 2 different cases or if it'll just end. I think it just ends after the first case that it runs. It just goes to the end, I believe. We could test that. That's a good question. I've never had anybody ask that question. So if we build one of these really quick, let's do it just the one they did. Letter equals input. Give me a letter. Right. Put it in as a string. New letter. So put a new. Okay, now I've got letter is now the string U. And then I go switch letter. And I go case. Let's just do 2 different cases. One that's U. And then we say F print F that worked case I don't even have to. Let's do that again. Let's see if it'll do 2 that are the same. And so it jumped out. Yeah. It just goes to the first one that it matches and jumps out. Because it matched both of those cases, right?
You wouldn't necessarily be slowing down the program if you had that ton of cases.
No.
Unless it's just one.
It's yeah. Unless it has to check through all of them to figure out which one works. But it's actually, but Boolean logic kind of stuff is pretty quick anyway, so it's not that big a deal. Okay. Any other questions about the switch case statements? Can you see now, though, where the flow charting can be useful as you get through these problems? Because this does start to get a little more complicated. How am I going to use these operators with these branching statements? Because when you start having the different programs going different directions, doing different things, it starts to get really important. So here they in section 8.4.5 they talk about the menu button, the menu thing that we already used and talked about, and that's great. And then they go on to talk about debugging some more, because of course when you make more complex programs, you're going to need more debugging. They also have some more commands at the end of 305, some more Boolean commands. They have the all and the any command. All checks to see if a criteria is met by all the elements in an array, or any checks to see if a criterion is met by any of the elements in an array. So it's kind of like the and the or statement. Let's see if we can do this. Let's actually ask for help with this. I don't think I've ever used this before. That's not what I want to do. Oh. Yeah. Okay, so if I have an array, do I have any arrays right now? I don't. Let's do an array of x equals 1. Let's open it up. So let's just fill this array with some numbers. Okay, so now we've got our array 6 by 6 double, and if we use this thing any on x, so the any function, apparently, it's true if any element of a vector is non-zero number or is a logical one true. So if it's, and then it's essentially treating each of the columns in the array as a vector. So each column has something that's non-zero in it in x, apparently. But if I do this, if I do are all the numbers in x, are they all non-zero? That's not true. The last column is the only one that has all non-zeros in it, right? In x. Here. If I open up x, x has one column that has all numbers that are non-zero. All the rest of them have some zeros in them. So what the any and the all are asking is, does this array have numbers that are non-zero in it? Yes or no? And if it's a multi-dimensional array, then it asks by column. Does that make sense? And then the all one asks, are all the numbers in this array ones? And it asks it by column. And you can do it element by element as well, I believe. You have to tell it how big the thing is, I think, if you do it by 6, let's see, vector dimensions, yeah, so you have to tell it how big it is by doing a 6 space 6 like that. Let's see. Is that, there we go. So you just tell it that's a 6x6 array, and then it returns however many. This tells you every number in the array that's non-zero, and tells you all the ones that are zero. The non-zero ones are ones, the zero ones are zeros. So that's another. Those are two more Boolean functions that are built into MATLAB. And that pretty much covers chapter 8. With a minimal amount of speed. Any other questions? We're done for today.